Okay, so like I said, today we're going to start with risk analysis. All right. And risk analysis basically is the next step or next stage after risk identification, after identifying all the risk and all the hazards. And risk analysis simply consists of firstly identifying the consequences and their probabilities. That is what the consequences of the hazards, okay, the severity of consequences, and the probabilities that this for identified risk events. Okay, what's the probability of this happening? And this takes into account the effectiveness of existing controls as well. Okay, what are controls and how effective these existing controls are. So basically, in risk analysis, we want to firstly determine the consequences of those risks that you've identified, their probabilities or their likelihood, and if their existing controls are effective, how effective these controls are. All right. So basically, the consequences and probabilities are combined to determine the risk level. So basically, the risk is usually an expression of risk is usually an expression of consequence multiplied by the likelihood. All right. So now in that case, there may be other factors, as you see later. We're going to talk about that. There might be other factors, but this is basically the most common form to express risk. Now, the purpose of analyzing risk is to gain an understanding of the risks that are important to organization. Now, someone could say, why don't we just treat all the risks that have been identified? Why do we need to carry out a risk assessment? Once we've done a hazard or a risk hit, why don't we just provide controls? The reason is because not all those risks are considered as affecting the overall goals and objectives of an organization significantly. All that means is that some of those risks, even though are important, you can simply just provide controls for them. But some of them, you need to prioritize them because of limited resources, limited time, limited resources, limited time, and also how to manage these risks. So basically, you have what you call the Pareto analysis, where you have what you call the 80-20, okay, or 80-20. So we have 20% of the risks contributes to 80% of the hazards. Okay, so basically, we're saying here that the losses in the organization, business losses and things like that, is due to 20% of the identified risks, not all the risks. So some of the risks we will not say they are not important, but they are not as important as this 20 that affects 80% of the business losses, organizational losses, or affects 80% of the objectives of the organization. So in that case, we need to carry out a risk analysis to identify these 20 or to properly analyze these 20 and then to rank them, to prioritize them, that we can deal with the risk in a more systematic and a more informed way. So this arrow shows the general process of risk assessment, starting from assessing the severity of the consequences. Okay, that's the one after you've identified the hazard. Then the next thing is what to assess the consequences. Okay, this is the risk analysis process. The next is to determine the probability of occurrence or exposure, any of that. The next stage is to define the initial risk level, which comes from both this and this. Okay, and basically, like I said, it can be simply a multiplication formula where you multiply the consequences with the likelihood of occurrence or the probability of occurrence. Once you identify the initial risk, you can reduce the risk by implementing controls. By the way, this initial risk will also take into consideration the existing controls. Okay, but because you're defining the initial risk in light of what controls are currently existing, how are the existing controls factored into the calculation of risks to tell you that this is the current level of risk at the site or the facility or in the workplace, or in the machine, or the design, or in the system. And then after that, you want to reduce this risk by implementing more controls, by suggesting controls, such as using the HOCs, hierarchy of controls. Okay. So when you use the HOCs, you use this to bring down or reduce the risk. And then after that, you assess the residual risk. The residual risk means the remaining risk after implementing what? Additional controls. So this is the last stage of the risk analysis process, where you assess the residual risk. All right. Now, if you look at this diagram here, the next one, you can see that this is the overall risk management framework. And you can see that there are quite a number of tools that can be used for risk analysis. Okay, one of them is cause and analysis, the other is likelihood and consequence analysis, and the other is called control analysis. Okay, so the first one is identifying the cause, okay, analysis of the effects, okay, or cause analysis means identify what is the cause of this hazards, okay, and what triggers it, what triggers the hazard. And then next, talk about the likelihood and consequences, okay, where you talk about what is the likelihood of occurrence or exposure, and what is the consequence of exposure. You can see there are different methods that can be used. You can use bow tie, HAZOP, LOPA. You can use the PHA, and things like that. Then you can use risk analysis, which is controls analysis as well. You can try to analyze the effectiveness of the controls that have been put in place. Okay, you can see hazard analysis and critical control points. You can see design mode, failure mode and effects analysis, LOPA, HAZOP, SWIFT, strip bow tie. So basically, these are various tools that can be used for risk analysis. All right. Now, let's talk about the risk factors. Risk factors are, as we said, are mainly the likelihood and severity. Okay, mostly the consequence. Okay, the severity of consequences, consequence, and the likelihood. However, there could be other risk factors. Okay, there could be other risk factors, but these are the two general factors, and usually it's in two dimensions. Okay, as you can see in this photo. You have the risk equal in the severity. Severity, by the way, again, like I said, is also severity of the consequences. Okay, this is what we mean by when we say severity. Multiplied by the likelihood. Okay, you can see it goes from incidental to catastrophic and from unlikely to frequent. And you can see the risk matrix is defined this way. We're going to talk more in detail about this later on anyway. So you can see here, the green, very green area is very low. Very red area is what's very high. I see here is medium. Okay. I can see green here is low, something like this, and this is high, things like that. So you can see the partitioning of the risk matrix, and this will be used for evaluating the risk. Okay, so we're going to talk about this in another chapter or another lecture. This will be for evaluation of the risk. But now we're only interested in analysis of the risk, and to analyze the risk, we need to determine the risk factors. Okay, we need to determine risk factors. The most common risk factors are the consequence and the likelihood. How do we determine these two factors? This is what we're going to talk about subsequently. Now, these are other risk factors, as we said. We could have exposure, which is used as a general measure of exposure events and units. Sometimes, instead of frequency of occurrence, we may want to consider frequency of exposure. Time duration of exposure is used as a time period that a single exposure occurs. You have vulnerability, especially when you have security threat analysis. Okay, this usually refers to the weakness in the system. Okay, also uses in emergency management, where we consider weaknesses in the community. Okay, the vulnerability of communities to various natural or technological disasters or hazards. Now, detection of failure as well in FMEA, usually used for systems and machines. And the detection rating is based on the estimate of how easily potential failure could be detected. Okay. Similarly, control reliability, usually used in machine risk assessment. Okay, to assess the reliability of a selected control into factors reliability of selected control into the risk estimation. Similarly, prevention effectiveness. Prevention effectiveness is simply used to consider the existing controls, okay, or consider controls, okay, as recommended controls into the risk assessment. So when you have, for example, to determine the initial risk, okay, you have the risk, initial risk, okay. Usually the initial risk is going to be equal to the consequence, okay, multiplied by the likelihood and multiplied by the prevention effectiveness, okay. So the prevention effectiveness takes into consideration the existing controls. Similarly, once you want to calculate the future risk, you still need to use the prevention effectiveness of recommended controls to determine the final risk or future risk levels, okay. So this initial control likelihood times the prevention effectiveness will tell you or give you information of the estimate of the risk levels. Likewise, you can see consequence analysis. So consequences basically are the result, outcomes, or losses of an event caused by a hazard. Okay, so this could be in terms of losses of lives, property, equipment, damage to the environment, and things like that. So basically, we consider people, okay, when you talk about consequences, assets and property, okay. We can consider the environment as well when you talk about consequences. There could be also other concerns like business losses, okay, downtime, shutdown, delays, business interruption. All this could be other consequences as well that you may want to consider. Now, the assessment team determines the nature and type of consequences that could result from exposure to a particular hazard or event. So usually you determine what kind of consequences you want to consider in terms of people, assets, property, environment, business losses, all this. What are the various types and natures of the various consequences that will result from the risks that you have identified? Now, a single hazard or event may produce many consequences of various magnitudes, okay? Now, the assessment context determines the type of consequences analyzed and stakeholders affected. Now, when you're carrying out your risk analysis, you consider the worst credible case and not the worst conceivable case. Now, what's the difference between the two is that the worst conceivable case is usually the extreme case, okay, which is not likely to occur. It may occur, but with a very low probability. Okay, that's the extreme case with a very low probability. Okay, extreme case with a very low probability. Whereas you could have credible, worst credible case. Usually, this is that it is realistic. Okay, it's the worst case, but it's realistic. It is more realistic. Okay, to happen. So you calculate, you base your risk assessment on this and not the worst conceivable case. Now, in determining the consequences of your risk, you can see that we have various, there's different various ways to characterize the consequence. One of them is the severity levels of consequence to be used in assessment should be determined upfront during development of the context. Okay, when you establish the context of the risk assessment, usually this is the time where you determine the severity levels that you want to consider. And this will include the types of consequences and levels of severity. So it's important that severity categories are clearly defined so that consequences can be consistently ranked or scored by a risk assessment team. So here now, before you start your risk assessment at the beginning, you have to make sure you clearly define what are the severity levels you're going to consider. And that's why I usually consider this during the development of the context. Okay. Usually you can use preset standards, okay, from your organization, guidelines from the industry, from government regulations, or you could develop one by your team or through together with stakeholders in organization, and this has to be endorsed and approved by the risk owners. That is top management, okay, because they are the ones responsible for the consequences of anything going wrong in the organization. So you can see it's an example of a severity category from catastrophic, and this is just 1 to 4. Don't forget that we have 1 to 5. Okay, this is 1 to 4. We have negligible, marginal, critical, and catastrophic. All right, and you can see the description of each level. This is considered the injury levels in terms of people. Okay, and this is considering what financial loss levels. Okay, in terms of or business losses in general. So you can see here that financial losses could involve property, okay, could involve business, all right, property, etc., okay, business and other things. So you can see fatality or permanent total disability to a person, and you can have estimated losses over $1 million US. While negligible is something simply requiring first aid or minor medical treatment with at least 10,000 US in losses. Now, the thing here is that this varies with various organizations. While for life safety might not be very flexible, but in terms of property and other business losses, what is considered to be negligible may be relative, okay, or subjective. So, for example, 0 to 10,000 US is negligible to some companies, but for some other organizations, anything less than $1 million may be negligible, or at least something less than 100,000 US, depending on the scale and complexity of the project or the system that is being considered. Okay. Now, this is another example of consequence severity category and description. You can see this comes from 1 to 5. Okay. And here we have it in other various domains, the kind of impact that you are considering. Like we said, we could have multiple impacts. So this one talks about impacts to injury, general safety within the organization, that's in terms of accidents and emergencies and how they are responded to, damage of property in the organization, environmental impact, and public impact. Okay. Now you can see that injury, you can have other domains or other impact factors that you want to consider. Okay. And this could be fatality, okay, disability or permanent life-threatening hospitalization, lost time from work, medical aid, restricted work, first aid. You can have disasters in this case, and then you can have just regular emergencies in this case for safety. And the first disaster, this one requires external response, while this one requires internal response. The other one, you could require emergency response within. It's just an emergency, but requires external agencies to be involved, while this one is potential emergency response internally. And this is something that you simply report its occurrence, but is not considered as requiring any response. Next, in terms of property damage, you can see here it's considering catastrophic to be anything greater than 250,000 US. And this could vary, like I said, with different organizations. And here, anything up to $1,000 is considered minor. Whereas for some other organizations, anything up to 10,000 or 100,000 may be considered as minor. So this varies depending on the risk owners and what kind of risk, what is their risk tolerance, okay? Risk owners and their risk tolerance. What level of risk are they willing to accept? Next, you could have environmental impact. What's the impact on the environment in general in terms of impact to the public? And this can be the area of coverage, especially have release of toxic materials or flammable explosive materials. What is the area of coverage of this hazardous scenario? And how many people could be potentially affected by it? So if it has an impact to the general public, outside the facility, or you have an offsite release and you have the release is contained or within the facility, or contained with the facility minimal impact, contained with facility no impact. We have these various categories of the environmental impacts, and then this is considered as various levels for environmental impact. You can also have other public impacts, like large community or small community, or just families and or a neighborhood, or just one individual, or no impact on the public. So you could have some other categories like business losses, where you lose some of your partners, some of your investors, downtime, shutdown of your plants, delays in running your product. All this may also be factored into determining the severity and the consequence of the risks. Now, something else usually done in consequence analysis, what you call QRA, consequences for QRA, quantitative risk analysis or risk assessment. Now, in determining the consequences, this takes a more engineering and scientific approach to analyzing the consequences of the risks. Okay, well, consequences may be determined through here by using standard formats and some basic estimation of the consequences, as well as historical information on similar accidents in that same facility or in similar facilities in other places. You could also do what you call quantitative risk assessment, where you analyze the consequences of a spill or a release of a toxic substance or flammable substance, any kind of hazardous material, where you have the release into the environment. It could be due to loss of containment, okay, release of a toxic substance in liquid or gaseous form, or the release of a potentially explosive and flammable substance that could lead to an explosion or that could lead to fire, right? And this could lead to overpressure, blast overpressure, affecting all the areas around that particular location where the unwanted scenario, risky scenario occurred, or a lot of pressure, blast overpressure, or heat coming from this fire, or release of thick smoke and damage to the environment, or as well as toxic inhalation of toxic substances or spread of this kind of toxic substances. So basically, what is the area of coverage? And what are the kind of things that it affects in terms of people and property and the environment? All this can be estimated through a more scientific approach. You can refer it as consequence analysis. Now, this is outside the scope of this lecture, but I simply wanted to mention this to make the discussion complete. And you can refer to useful resources or materials at these links, okay? There's some useful resources and materials at these links that can give more information on consequence analysis software. For example, you can use the Aloha software. You could also use the there's another software provided by DMV, GL. Can't remember the name right now, but they have another software also that can be used for QRAs. Okay, so you can find some of this information out there, and this can help you to more scientifically determine what are the consequences of those potential risky scenarios. The next thing is to look at the other factor or the other common factor of risk assessment, which is the likelihood of analysis, okay, or probability. So in determining probability, we can simply look at three main sources or three main approaches. One of them is to refer to historical data, relevant historical data, okay, that will tell you events that have occurred in the past and the conditions surrounding their occurrence, and how we can use it to determine future occurrences or the likelihood of future occurrences of these events. Method used in fault analysis, for example, you can try to identify the root cause event, and for each level, you identify what could potentially go wrong and what could lead to that on the next level, and what could lead to each that on the next level. And for each level, we try to identify the probability of that and then combine the probability of occurrence of the overall top event. Eventually, an invert of the fault tree analysis, an inverted process of the fault tree analysis. Okay, identify various causes until you come down to the main event. So the fault tree analysis, you invent a main event and you try to trace it down to the what various specify the probabilities of occurrence, and then you can come up with an overall probability to determine the overall probability of the potentially risky scenario. Now, a structured systematic process guided by qualified, knowledgeable experts is experts' opinion, experts' judgment. Okay, you can seek the professional judgment of experts in the industry that can give information based on this. And these experts could also come from a group of experts. Okay, that's why you see in brackets, you have experts. A group of experts in the team can come to a consensus, all right, because they might have slightly different opinions, and then a consensus might be achieved by this expert, which is more reliable. Okay, Also, regarding the first approach where you use relevant historical data, this may also be very, very crucial, especially in a time where we are trying to use digital methods like machine learning to extract information from historical data and make predictions of future possible occurrences of these risks based on past historical indicators and conditions are surrounding the occurrence of that particular event. Such information could be used to predict past actions. So basically, these are the three approaches that can be used to estimate the likelihood of analysis, likelihood of the event. Now you can see here also we have descriptions, and here where you can talk about the likelihood of occurrence and the various categorizations, usually from 5 to 1, or it could also be 4, as you can see in the 5 to 1 here as well. This is probably 4, and probable 5, sorry, 3, and this is 2 is 1. Okay, but this is, I think, this is the same thing as well. Sorry, this is 5, or occasional is 3, remote is 2, and this is 1. But anyway, so these skills are using 5, but it could also be 4, depending on what is used by that particular organization, what is common, and what is approved by the risk owners and the stakeholders. So you can see frequently for here, he's saying, for example, 1 in 100, which could mean 1 in 100 days, 1 in 100 hours. Okay, it means that makes it very frequent, or 1 in 100 opportunities, or 100 instances. All right, whereby you have 100 instances of the use of particular equipment, or the setting up of a particular system, or occurrences of or carrying out a particular activity. So when you have an accident happening one time out of these 100 potential occurrences, potential use of or potential opportunities, then this is considered as frequent. Whereas you could have 1 in 1 million, which seems quite very unlikely, when if this is the evaluation of the likelihood of the risk. Similarly, you see that we have here something that is frequent, happens once in the last 12 months. Conditions for exist for it to occur, or something that is unlikely, has not occurred within the last 5 years. And the conditions surrounding it makes it really possible. Okay, conditions really exist for it to occur. If you look at this as well, we have frequently, which is weekly, 1 to every 4 weeks. And you can look at improbable, which is very unlikely to happen, once in a century, which is about once in every 100 years or more, which makes it really improbable. Okay, so this depends, on what kind of risk we're talking about, and then the organization may come up with their own templates or formats for the risk analysis categories for likelihood, as well as for consequences. This might also be available in guidelines, in standards, in codes, or the company itself might have a particular template that has been adopted and used and relied on for many years. Something else that may be considered is the exposure. Instead of considering the likelihood of occurrence, it may be likelihood of exposure. Here it says that where historical data shows a very low frequency of occurrence, it may be difficult to probably estimate the probability. Okay, in this case, you have very low occurrence historically. In this case, you might have to go for the exposure, because even though it occurs less frequently historically, however, it's have very large exposure. A lot of people are exposed to it. Property is exposed to it. And so when it occurs even once, the damage is catastrophic. In this case, you might want to consider the likelihood of exposure instead as a more accurate representation or analysis of the risk. So it may be necessary to consider exposure frequency, time, duration to a certain hazard or event in the likelihood analysis. So exposure is an indication of the event to which the organization is subject to the consequences based off the amount of exposure in numbers. So exposure can be measured as frequency of an event or exposure, its duration, or the assets exposed to risk. So some of the variables for exposure might include: 1, the number of employees or people exposed, how frequent the activity is being performed, the miles driven if for transportation, if you're talking about hazardous materials, for example, the number of customers or products for a product risk assessment, talking about a product that's been released into the market. How many people do you think this are going to use this product? Typically, number of products released. Okay, so these are number of people that will be exposed to it, or people that may come in contact with this product. Number of locations or facilities for a property risk assessment. Okay, how many facilities, especially for very large organizations that have multiple facilities in various locations. We want to also determine how many facilities are there and how many people may be exposed to a particular kind of risk in these facilities and things like that. So here you can see here, this is another table that shows the description of the exposure for frequency of exposure as well as frequency of occurrence. You can see we're having from frequent to improbable as well. So there's one interesting point here which is called FSI. Okay, FSI means fatal or serious incident. Now the frequency of occurrence may not be a valid predictor of likelihood, as we mentioned earlier, or probability, unless occurrence data is higher in probability than exposure. So this is the condition. If you have occurrence higher than exposure, okay, then in this case you can go with occurrence. Otherwise, you use the higher of both. You use either exposure if it is higher. If occurrence is higher, you use the frequency of occurrence. So it means in that case, you need to identify the frequency of occurrence or analyze frequency of occurrence. Sorry, and frequency of exposure as well as frequency of occurrence. And you use the higher of both of them, especially for FSIs. That is fatal and serious incidents. Because this fatal and serious incidents, even when they occur once, the consequences are extremely high. So to simply use a low frequency of occurrence. So you can see here, exposure says if task is performed several times an hour, okay, and our duration may approach at least 4 hours a day, then you call it what? Frequent. The exposure is frequent. If tasks may occur only under exceptional circumstances and are completed in just a few minutes, you call this improbable. Okay. Task duration typically under 1 hour is called occasional. Okay, so basically you can see here, this is one way to describe the frequency of exposure, and we also have a way to describe the frequency of occurrence. So I think we're going to stop there. Next time we're going to look at some of these examples in our previous discussions. Now we're going to just discuss some of the questions that you guys may have on what we've discussed so far.